So in this video, we're going to continue to solve some real-world problems using algebra, but it's going to be a little different this time because we're going to be using formulas to solve a problem. So what is a formula? Well, a formula is an equation that describes a known relationship among quantities such as time, distance, volume, weight, money, and there's other quantities that you'll see as well. But anyways, formulas are valuable tools because they allow us to calculate measurements as long as we know certain other measurements. And from my personal experience, I can tell you being able to use formulas to solve problems is extremely valuable in the rest of your math career in pretty much any field or subject where numbers are involved. I'm not going to try to go over any formulas, not any specific ones at least, because there are just so many of them in so many different areas, and you'll keep learning new ones as you continue the rest of your academic career from basically any subject that uses numbers: economics, physics, chemistry, biology, basically everything. But let me use one formula that you probably already know, and I think I've used it in one of my videos at least. The area of a rectangle. So the formula for an area of a rectangle is area equals length times width. Or you might see it more often than not, A equals LW. Either way you write is fine. Most people just use the variables A, L, and W just to say time and space writing. So you just have to know what these variables represent. The A stands for area, the L for length, and W for width. And the idea when we're using formulas to solve problems is that if we have a value for each of the variables except one, then we can find the value of the unknown variable using this formula. So if we know A and W, we can find L, and if we know the length and width of the rectangle, then we can find the area of the rectangle. So to solve problems, we're going to be using the same steps: understand, translate, solve, and interpret. It's going to be in the understand step that we will decide which formula we need to use to solve the problem. So here's the problem. A volcano has erupted and the lava is flowing down the side of the volcano towards you at a rate of 7 meters per second. If the path the lava flows from the crater to you is 784 meters, how long does it take the lava erupting from the crater to reach you? And I drew a little diagram or picture down here to show you what's going on. So we have, there's the volcano, and up in red is the lava, there's the crater, and it's flowing down here. This might not be specific when we say where's the crater, where's you, and how long is the path is, but all we're saying is that definitely we're using numbers to say it's 784 meters from wherever to wherever. Just know that it's 784 meters. That's the distance that it's traveling, and it's traveling at a rate of 7 meters per second. So this is what this arrow here represents. So like I said, it's just a basic view, but it's good enough for this problem. Now let's look at what we're given and what we're being asked to find. So I've done this before and I'll do it again. We'll make a given and find columns. So given and find. So this is we're gonna put down the information that we're given in the problem and the information that we're being asked to find. So the information that we're being asked to find, I'll scroll back up here, and you can usually find it in the last sentence of the problem. So how long does it take the lava erupting from the crater to reach you? So that's what we're being asked to find. And I'll put that down here. I'll just call it time for lava to reach you. And the information that we're given, we can also find in the problem. And it says a volcano has erupted and the lava is flowing down the side of the volcano towards you at a rate of 7 meters per second. So typically it's going to be where the numbers are is where the given information is. So a rate of 7 meters per second, that's how fast the lava is flowing. If the path of lava flows from the crater to you is 784 meters, so that's how far the lava flows. So we got the rate and the distance it flows. Okay, so I'll put that down here. Lava flows at rate 7 meters per second. And then the other piece of information is lava travels 784 meters. Okay, so that's the information we're given and the information we're being asked to find condensed into a little table. Now notice here that we have a distance right here. This is a distance right here. I'll just put D for distance. And we also have a rate right here, R for rate, and then we have a time over here, time for lava to reach you. So if we have a distance, a rate, and time, then we can apply the formula distance equals rate times time. Or as we put the variables up there, D equals RT. So distance equals rate times time. So if you're familiar with this formula, good. If not, you'll get familiar with it over time. But what this formula tells us is that we can find the distance something travels by multiplying the rate at which it travels by the time it travels. So when we use the term rate, we're talking about how much something does something over a period of time. So in this case, the lava is traveling a distance of 7 meters for every 1 second. So 7 meters per second. And when we're talking about a rate of distance over a period of time, we can also use the term speed. So the lava moves at a speed of 7 meters per second. Alright, so now we can plug in the the values that we know into our equation. So we have, for D, we found it to be, or we were given that it was 784 meters. So I'll put that in there. And then we also were given the rate to be 7 meters per second. 7 meters per second. And the time we weren't given, it's unknown. We're being asked to find it, so we'll just leave it as T. So that's what our equation looks like now. We've got two values, and the third variable, the unknown one, T, is what we're being asked to solve for. So now we just need to isolate T, and that will allow us to solve for time. But before I solve for T, let me ask you, we have units on D and we have units in R, but what should be the units on T? Well, T stands for time, so we have meters on the left here for distance and meters per second on the right here for rate. Shouldn't T be in seconds? Remember, units should balance out, so we can check this. On the left side, I'm just going to check this in red, I guess, over here. On the left side, just worrying about units, we have meters. And then on the right side, we have meters per second. Now I'm just going to assume that T is in seconds. And we're going to check and see if this works out. So we have meters on the left and meters over second times second on the right. Now these seconds cancel out here, one on the denominator and one on the numerator. So that just leaves us with meters equals meters. So yes, this checks out. And what this tells us is that seconds is indeed the correct units for time. Now I could have been more mathematically rigorous, I know, and kept the units for the rest of the problem, but what's important right now is just getting the numbers down. But I still wanted to show you why seconds is the correct unit. Now I'm just going to remove the units, and then we'll remember to put an S for seconds in our solution. So we've got 784 equals 7t. Just took away the units, and now to solve for t, we simply divide both sides by 7. So on the left side, you can use a calculator if you want, we get 112, and on the right side, these 7 cancel out, so we're left with t. And then that means our solution is t equals 112 seconds. And what does that mean? We have to interpret our solution. So what does t represent? Well, up here we said t represents the time for the lava to reach you. So we were asked to find, and then we found the time it takes the lava to reach you to be 112 seconds. But does that make sense in the context of the problem? Well, let's think about it this way. How far will the lava travel if it is flowing at a rate of 7 meters per second and it flows for 112 seconds? So each second it travels 7 meters, and then we multiply that by 112 seconds. So we got, just use in black, we've got 7 meters per second. That's the rate, and it goes for 112 seconds. And what is that going to give us? So we have it going 7 meters for every second for 112 seconds. Just like before, the s cancels out, so our answer is going to be in meters. Makes sense, it should be a distance. So 7 times 112, you can check out to be is 784 meters. So that means that the lava travels 784 meters in 112 seconds, which is what we were given in the problem. So that means that our solution is correct. I'll make my concluding statement quickly. We were asked to find the time it takes the lava to reach you, so we'll say the lava will reach you in 112 seconds, assuming you're not smart enough to move away. Alright, that's all I have for this video. I'll see you guys in the next one.